Hi everyone. Today we are going to discuss about gas tube and Coolidge tube. I am Gauri PS, lecturer, Department of Radiography, Global College of Analytical Sciences. First, X-ray tube evolution and the working principle. These are topics we are going to discuss. First is about introduction. First, X-ray tubes are the devices that produce the X-rays. First, gas tube was the used X-ray tube, and the Coolidge tube is the modern hot cathode X-ray tube. And these are usually used widely in radiology and medical imaging. Next is discovery of X-rays. First X-rays was discovered by Wilhelm Conrad Röntgen in 1895. Initially, the X-ray tubes, that is X-rays produced, was by means of a gas discharge tubes. That is, after this, it led to the development of Coolidge tube in 1913. First, gas tube. The gas tube is also called as Crookes tube, and it contains low pressure gases. The electrons are produced by the ionization of a gas, and it is an early method used for the X-ray production. Next is about construction of a gas tube. How is the construction made? That is, the gas tubes are filled with cathode and anode. It also contains gas, whether it is a partially it is vacuum, but with the traces of gases. And a high voltage source is connected, and the target will be acting as an anode. In the beginning, the gas-filled tubes were used to produce the X-rays. And these tubes usually consist of two electrodes, that is cathode and an anode, which are kept in a sealed gas envelope at opposite ends. The cathode is an aluminum stem which carries a concave aluminum disc, and anode is, or the target is, a tungsten or a platinum which is backed with copper. The radius of concavity of the cathode will be such that its center of focus will be lying on the surface of the target. The face of the target will be makes an angle of 45 degree with the axis of this cathode neck, and there is a provision which is made in the tube to different degrees of vacuum, and this tube vacuum must be always less than 0.001 mm mercury. Then next is about working of a gas tube. Usually, it high voltages ionizes this gas, and the positive ions strike the cathode by releasing of electrons, and the electrons will be accelerating towards the anode, and the X-rays produced when electrons hit their target. That is, in a gas tube, there will be a small residue of air which will be left in the tube itself. So, when a high potential is applied between this cathode and anode, the air inside the tube will be ionized and the electrons will be produced. And these electrons will be moving at a higher speed towards the anode, and will produce an avalanche of electrons by the collision with the air molecules. And the positive ions which are left will be attracted towards the cathode, and they will be releasing many more electrons due to its impact. So, when the electron beam strikes the target, the X-rays will be emitted, that is, X-rays will be producers. Next is about advantages of gas tube. So, what are the advantages will be there? There is, it is simple in its construction, and it has an historical importance, that is in the X-ray development, and will be demonstrating the X-ray production principles. If there is an advantages, there will be disadvantages. So it also has some disadvantages, such as the output will not be as stable, and has a poor control over X-ray intensities. It is a low efficiency, and hue hardening effects will be occurred. That is, the ionization potential of the gas will be depending upon the degree of evacuation of the tube. A tube with much residual gas will be producing the X-rays at lower voltages. But if the voltage increases beyond the ionization potential, the tube current will be increasing enormously, and it will be melting the target. So the whole tube will be filled with the vapor of target material so that it makes the tube gassy. The energy and the intensity of the X-rays will be interlinked. That is, to increase the penetrating power, the evacuation has to be increased such that by applying an higher voltage. So a vacuum pump is always required throughout this operation. So there is an apparatus required. So the apparatus will be requiring a higher skills to operate. So next, as the tube will be operating, the ions will be gradually diminishing. So it will be resulting in a higher vacuum. So a fresh gas has to be injected into the tube by the use of a gas generators. So this is also a difficult process. So because of these all disadvantages, the gas tubes are now practically not in use. The next we are going to look about is about Coolidge tube. The Coolidge tube was invented by Wilhelm D. Coolidge. It is William D. Coolidge, and he uses heated tungsten filament, and the electrons will be produced by the thermionic emission, and it is a modern diagnostic X-ray tube. That is, the Fleming and Richardson showed that when a metal is heated in vacuum to incandescence, it will be emitting a large amount of electrons. Such an emission of electrons by the supply of heat will be called as thermionic emission. So next is about construction of a Coolidge tube. How will be the construction of a Coolidge tube? It also consists of an glass envelope with cathode as a tungsten filament, and there will be a focusing cup that will be directing the electrons, and tungsten will also act as a target. It also, that's a high vacuum which is present within the tube. That is, the in the Coolidge tube there will be cathode and anode which are kept in opposite to each other, and there will be electrons will be focused by means of a focusing cup. So these electrons will be produced by using another electrode which is opposite at a positive potential. So it is proved that all the emitted electrons can be collected at a particular potential. It is called as a saturation potential. So further increasing of the potential does not increase the current flowing between the electrons. So next is about working of a Coolidge tube. The filament will be heated by low voltage current, and the electrons will be emitted from the cathode. The high voltage will be accelerating the electrons, and the X-rays will be generated at the tungsten target at the anode. So the new tube just designed by the Coolidge made use of the thermionic emission principle. So it is also called as hot cathode or electron tube. So this tube is highly evacuated so that there will be no air, also gaseous material. So there will be no production of electrons by the process of ionization. A spiral of wire which will be serving as an hot cathode will be heated to incandescence, that is by means of an current of 4 ampere and 10 volts. The filament which is commonly used is tungsten. A target is placed opposite to the cathode, that is similar to that in a gas tube. So when a high voltage is applied between the cathode and an anode, the electron current will be flowing from the cathode towards the anode. So as a result, the electrons will be reaching the target and the X-rays will be produced. So these tubes will be always operated as a saturation potential. The wavelength of the X-rays can be controlled by altering the voltage which is applied to the tube. The tube current can be varied by altering the temperature of the filament. Thus, the applied voltage and tube current are independent of each other and can be controlled separately. So that is the advantages of this tube. So usually all this modern X-ray tube will be formed on the basis of this principle of Coolidge tubes. So next is about advantages of a Coolidge tube. So what is advantages? It has a stable X-ray production, and it will be better in the control of tube current, and it has a high efficiency, and it will be improving the image quality. So next is about disadvantages. There is advantages, there will be disadvantages. So disadvantages consist of, that is, it will be requiring an efficient cooling. So the when usually a tube, when it is heated, there will be heat surrounding over the tube. So it has to be perfectly cool with a certain intervals. So it requires an efficient cooling, and it has a complex construction, and it is expensive just compared with the gas tube. So next is about comparison between the gas tube and a Coolidge tube. The gas tube will be using the ionization of the gas, whereas the Coolidge tube will be using the thermionic emission principle. The gas tube has an unstable output, whereas the Coolidge tube provides a stable and a controlled output. So next is our application. Where do this gas tube and Coolidge tube are applied? They are applied in the medical radiographic process, fluoroscopy, industrial radiography, and in scientific researches. Then what are the safety precautions we has to be followed? The safety precautions consist of using of a lead shielding, limited exposure time, maintaining a proper distance, regular equipment maintenance, etc. So, what is the conclusion? So that we can conclude that the gas tube was the foundation of an X-ray technology, and Coolidge tube revolutionized the diagnostic radiology, and the modern imaging systems uses this improved Coolidge tube that has made the revolutionized diagnostic radiology. So that's all for today's topic. Thank you.